Hi, today we're going to talk about confidence interval. So first of all, what is confidence interval? First, let's do some review. What is population? What is sample? So in statistics, parameters of population are often estimated based on a sample. Why is that? Because we know that population usually is all of the data. It's very hard for us to connect, so that it's hard for us to just estimate the population mean or standard deviation. In that case, we will draw some samples from a population and try to estimate the mean from the sample or estimate the standard deviation so that we can use that to estimate the population parameter. So, for example, let's say if I want to estimate let's say we want to know the average math class passing rate in SPSCC. So what we will do is, instead of investigate every single classes in SPSCC, we will just draw some sample from the population. Let's say this is SPSCC. Right now, we don't know the average, the passing rate for the math class. What we will do is we draw a sample. Maybe we will investigate 2024, the business class. This is our sample. This is one sample. Or we will draw another sample, which is maybe 2022 nursing class, the nursing students passing rate. Or we will draw another one is 1919, the bio major classes, how's their math passing rate. So from here, we might receive a different passing rate. For example, the mean of a business class passing rate maybe is 70%. For nursing class, maybe is 81%. And then for bio, maybe is 75%. As you can see, you will expect it, the mean might be different. Maybe if we're lucky, one of the sample mean will align with, will be exactly the same as the true mean of the population. But most of the time, no. So that's why we have a confidence interval, because it is very useful to know a range in which the true value will lie with high probability. So in this case, okay, maybe the passing rate is in between 70% to 85%. So the mean, the population mean or population proportion will lie in this range. So this is a confidence interval. So in order to figure out what is confidence interval, first we need to know what is standard error. Standard error is an estimate of a standard deviation of the sample distribution of a proportion. It is used when we don't know the value of P, which is the population proportion, and are not able to determine the true standard deviation. So the standard error is equals to the proportion, the sample proportion, and then Q hat equals to 100%, which is 1, subtract the sample proportion, and divided by the sample size. N is the sample size. Okay, let's look at the example here. A survey of 2,500 HR professionals showed that 1,200 use social networking site to research job applicant, state the sample proportion, and calculate the standard error for the sample proportion. Well, right now, we know that, hey, in a survey, with this survey, we know that 12,000 will use the social networking out of 2,500 people who take the survey. So that the sample proportion is going to be p hat is 1,200 divided by 2,500, which is 0.48. And the sample size is 2,500 since you surveyed 2,500 people. Okay, so first of all, in order to apply the sample proportion, we need to check the central limit theorem. Do you remember the central limit theorem? We have three things. One is independence. We usually check that one because each respondent is not going to affect the other respondents' the survey result. So that's why they're independent. Second part is the randomization. This one we'll check. Next is the success and failure rate. So the success and failure condition, I'm sorry, not the rate. So for the success rate, we have the sample size times the proportion, which is 2,500 times 0.48. This part, if it's greater than 10, that means check. The success condition checked. And now the failure condition is the sample size times Q hat. Remember, Q hat equals to 1 minus P hat. So since P hat is 0.48, so that means Q hat is equals to 0.52. So times 0.52, this part also greater than 10, so that means the success and failure condition check. So that means we can apply for the sample proportion. This step is very important. Every time when you're doing sample proportion or sample mean, we need to check the central limit theorem. Okay, now we already found the sample proportion. Now the next part is to find the standard error. The standard error of a sample proportion is equals to, look at our formula, it's square root of p hat times q hat divided by n. So I got 0.48 times 0.52 divided by 2,500, which is equal to 0.009999. So in statistic, in this class, we will usually run up to keep 4 decimal places. So we can say this is around 0.001. Okay, draw and how sampling distribution model for the p-hat should look. Okay, so we know that since this is satisfied the central limit theorem, so that means p-hat is going to follow the normal distribution with a mean 0.48 and the standard error, which is the standard deviation of the sample, is 0.001. If we draw a graph, this is going to look like in the center is going to be the mean, and one deviation is going to be 0.49, and then subtract one deviation is equal to 0.47, and two standard deviation is 0.50. And the third three standard deviations 0.15 and 0.45. So follow the normal distribution. So here's the model for p-hat. So now let's continue. Based on the 65, 95, 99.7 rule, which is the imperial rule, where do you expect 95% sampling distribution p-hat will fall? So when we talk about this rule, do you remember that within the first standard deviation, the data covers 68% of the data. And then within the second standard deviation, we expected 95% of the sample distribution is going to fall in two standard deviation, positive or negative. So we expected 95% of the sample distribution p hat to fall within two standard deviation, which in our case, the two standard deviation is going to be 14.6 to 50, which is 14.6% to 50%. So that means the population parameter is most likely to fall within 14.6% to 50%. Okay, next one. Well, between what two proportion do we capture exactly 95% value, right? The interval that represent the proportion. We know that with two standard deviation, this is going to fall more than 95%. It's 95 point something percent. It's not exactly 95%. If we want to know where is exactly 95%, how do we find it? Now, think about that. This follows normal distribution. In a normal distribution, one thing that we know is this bell curve is going to cover 100% of the data. This is our p hat, which is our sample mean or sample proportion. And since this is symmetric, if we want 95% of the data to in the middle, that means these two ends, the right end and the left end, contains 2.5% of the data, so that the sum of these three parts equals to 100%. So how do we find that? We can standardize the normal distribution and to help us to find, hey, how far away from these two cutoff value. Think about the standard normal distribution, z, with the mean is 0, with standard deviation is 1. Now I'm going to open GeoGebra. So in GeoGebra, you already see my setting. This is a normal distribution with the mean 0 and 1 is standard deviation is 1. So now if we want this to contain 19.75 data, so the cutoff value in here is negative 1.96. On the other hand, if I want this part to contain 0.25 data, the cutoff value in this part is 1.96. So that means the cutoff value in here, if it's standard normal distribution, is going to be negative 1.96, and this one is 1.96 standard deviation, or standard error. In this case, we call it standard error. So how do we understand that? You can think about that the standard normal distribution is the zoom out or zoom in with the normal distribution that we are talking about. So that means if you have a negative 1.96 times the standard error of the sample proportion, that is going to be the cutoff value. In this case, this part is going to contain 2.5% of the data. Similarly to here, if you times 1.96 to the standard error. That means you zoom in the 1.96 to getting close to the standard normal distribution. This part contains the upper 2.5% of the data. So if we take out these 2.5 on the left and on the right, the middle is going to be the 19.5%. So in this case, this is 1.96 times standard deviation below the mean, and this part is 1.96 standard deviation above the mean. Okay, so confidence interval. So sample proportion plus or minus the margin of error, which is we use this formula. This is to create the interval of all the possible value with the true value of the population proportion. I'm going to use the previous example about the math classes. Right now, we have 70% and 18.5%. We know that the true value, the whole SPSCC schools math class is going to lie into this 70% or 18.5%. But if we want it to be more confident, maybe we can make the range even bigger. Think about it. If the range become, 60% to 19%, we will be more sure that, the true SPSCC students population proportion, P, is going to lie in this range. So how do we determine the range? Now we use confidence interval, this one. So the critical z-score is donated z-start and is determined by the confidence interval. The margins of error, ME, is equal to z-star times the sample standard error. In the next video, I'm going to explain more what is confidence interval for proportion.